Dr. Vinós, it's a pleasure to have you here. And you're presenting us your theory. You wrote a book, Solving the Climate Puzzle, Sun's Surprising Role, which was published last year.
Yes.
And we just heard some summaries out of that book and your approaches to climate change and the sun's role.
Yes.
So can you just summarize very briefly what it is about and what's the new thing about it?
Okay, this book presents a new hypothesis about natural climate change that I have developed based on lots of evidence that has been published in scientific journals, and that says that the climate changes naturally in a very important way through changes in the amount of heat that is transported from the tropics towards the poles. So basically, this has been ignored so far, and this could be very important because the greenhouse effect is very uneven on Earth. So it is very strong on the tropics and it's very weak on the poles because it depends on the amount of water vapor in the atmosphere primarily. And the tropical atmosphere is very rich in water vapor and clouds, but the polar atmosphere has almost no water, so the greenhouse effect is very weak there. So changes in the amount of heat that is transported are capable of changing the climate. And I have found that the sun, through its changes in activity, is a very important modulator of the amount of heat that is transported to the poles.
What should people understand from this book and from your research? So what should they take away from it? What is the takeaway message that you give with it?
Okay, the main message, I think, it would be that climate is extremely complicated. And then when we think we understand how climate changes and we want to implement policy changes based on this understanding, we are probably making a mistake because we don't understand how climate changes well enough to determine what should we do about it. So one thing is that there are some aspects of climate change that are actually very poorly known, and one of them is the change in albedo, which is the amount of energy that is reflected by the Earth, and the other one is about heat transport, which is the one that I am focusing on in the climate. So, and the second take-home message would probably be that natural climate change has not stopped. It is still acting, and changes in solar activity are a lot more important for climate change than it is generally considered by most climate scientists and the IPCC.
Can you explain us a little bit closer to someone who has not seen your presentation? When you're talking about the poles and the equator and this shift of energy or of like warm air, what exactly does it, and what are you proposing in that theory that you're showing?
So what I am showing is that there are a lot of articles and there is a lot of information supporting that what we're seeing is changes in the amount of heat that is transported both by the atmosphere and the ocean towards higher latitudes. And this is linked to many of the things that we are observing in the climate. So, for example, one very important thing is that there is a lot of talk about Arctic warming. It's called Arctic amplification. And it is generally believed that it's due to our emissions and to global warming, when in reality it appears to be mainly a result of the decrease in solar activity that has taken place since the mid-1990s. So what we're seeing is that many of these climate phenomena that we're blaming humans could actually have a very important natural component that it is not well understood. And I am showing that there's evidence supporting that natural climate change is contributing very importantly to the climate change that we observe.
The international audience says, or international research says, that climate change as we see it nowadays has begun in the 70s, roundabout, like this global warming. That's where we see an increase in temperatures. So why hasn't that started earlier then? What?
Yes, so we have observed through proxies, through indicators of climate change, that global warming started around 1820, more or less, but it has not proceeded continuously like our emissions have done, but it has gone up and down at different times. So from about 1945 to 1975, there was a cooling period, not very intense cooling, but there was some cooling. So we can say that recent global warming started in around 1976, basically, while our emissions were increasing strongly since the 1950s. So we have a period of very intense warming from about 1976 to the mid-late 1990s, and then since then global warming is continuing, but clearly we have to be able to explain why climate has been doing this different rate of warming and cooling over the past. And I think we have to look into natural climate change to explain these changes in the rate of warming over this long period. And clearly, since global warming started in the 1820s, it must have a natural cause behind, because our emissions really didn't take off until the 1950s with the industrialization of the world.
So you're not denying that CO2, for example, and methane have an impact. That's, you're saying there is an influence of those gases on the climate and on some warming, but it's not the main force.
Yes, exactly. I think that there is some effect from the changes in the atmosphere that we have induced, but I think this is overhyped. It is exaggerated. Because we are ignoring natural factors that are also contributing to the warming, and they are not being properly appraised because we don't understand very well how they act. And one of the things that I'm proposing is that we are not looking at the right places. So we should be looking at changes in heat transport, and we should be looking for a solar effect on climate. We don't have to look at surface temperatures. We have to look at what happens in winter in the Arctic and what happens in the northern hemisphere winters, because that's where the solar effect on climate more strongly manifests.
Okay, can you go deeper into that a little bit? Like
Yes, the mechanism is quite complicated, but the interesting thing is that this mechanism was actually proposed 50 years ago, and it has not been properly investigated because we have focused too much on the human effect on climate. But it starts in the part of the climate system that is most sensitive to solar changes, which is the ozone layer. So the ozone layer gets very much affected by changes in solar activity. So the change in solar energy in the UV part of the spectrum is about 3%, which is a lot. And it also changes the amount of ozone because UV energy creates ozone. So the ozone layer reacts very strongly to solar activity, and this results in a change in the amount of energy that goes from the troposphere into the stratosphere, and that impacts the polar vortex. So the polar vortex is very much affected by solar activity, and this affects winter circulation, winter atmospheric circulation in the troposphere. That depends very much on solar activity. So what we get is low solar activity tends to result in a weak polar vortex, and this results in warming in the Arctic and cold winters in the northern hemisphere. And more energy is lost by the Earth when there's low solar activity. But when there is high solar activity, the polar vortex remains strong throughout the winter. So the Arctic becomes colder, and northern hemisphere winters are warmer. There's not much cold air coming out of the Arctic. And since emissions from the Arctic are lower, the planet is able to conserve more energy. And this is what happened during the 1975-1997 period, when solar activity was quite high. So the planet conserved more energy and it warmed more. So this is how solar activity could have contributed to the warming that we have observed.
Can you explain to our audience, please, what you mean with this vortex? So just to make it clear what the meaning of it is.
So the polar vortex is a region in the stratosphere, but it also extends in the troposphere, where very strong winds circulate around the Earth, close to the poles. And polar vortexes exist in most planets that have an atmosphere due to the rotation of the planet. And they become very strong during the winter, the speed, because of the temperature contrast between the tropics and the poles becomes higher, and they reach temperatures of about 180 kilometers per hour. So this constitutes a barrier wall that prevents heat from getting into the Arctic. So the stability of the polar vortex depends on the amount of energy that reaches the stratosphere from atmospheric waves. So when solar activity is high, the speed of these winds is stronger because there's less atmospheric wave activity. So it ends up that the amount of energy that the sun transmits to the Earth, the changes in energy, are not so important, because the energy that changes the climate when solar activity changes is originating inside the climate system. So these atmospheric waves transmit energy from the troposphere into the polar vortex and are responsible for the strength of the polar vortex and the strength of heat transport. And what the sun does is just it modulates this energy that is transferred from the troposphere into the polar vortex.
So the polar vortex is essential for like cooling in the Arctic, or keeping the Arctic cool.
Yes, the polar vortex is essential to prevent too much heat being lost during the winter. So most people already know that the polar vortex determines what happens during the winter. So when the polar vortex is weak, the jet stream becomes wavier, and due to that, we have very cold air coming out of the Arctic, and we get very cold winters in the northern hemisphere. And at the same time, warm air is entering into the Arctic, and the Arctic is warming. So basically, this polar vortex is a mechanism that regulates the exchange of energy between the Earth and the space. So when we get a strong polar vortex, the Earth conserves its energy. But when we get a weak polar vortex, then the Earth loses more energy to space.
I have never heard about it in all this climate debate. Maybe you have, because you're dealing with these topics, but why do you think no one is talking about it? Is it too complicated for a normal population, or is the explanation contradicting the climate change perspective that is presented to us?
Obviously, if you want to convince the population of something, you need a simple message, right? But the climate is very, very complicated. So climate change is something that is very complicated. And when we have very complex phenomena, probably simple answers are wrong. We're going to need more complicated answers, and we need to consider all these factors that are not being taken into consideration. We have to think that climate science has been very much affected by politicians, by policies that have been involved, because from the early beginning, the United Nations got involved into this climate change thing and created the IPCC with the idea of estimating the risks of human-induced climate change. So from the beginning, they had the answer. And if you start your research thinking that you already know the answer, you're not going to look into many places that we should be looking into.
Do you think there's a political indication behind there, like a political that's politically driven why this is, or?
Yes, I think it is so very much. And I think that when you mix science and politics, all you get is politics. The science is lost in the way.
Okay. I think we haven't talked about the winter gatekeeping hypothesis.
Yes.
That is also very essential to your work.
Mm-hmm.
It basically states that if the solar activity, like the activity by the sun, is low, more heat will be transported around the globe the poles won't lose energy and the global temperature stays low. What kind of implications does that have? And is this theory well known, or is it?
No, this theory is not very well known because I've just published it, and I am not a climate scientist. I am a molecular biologist, so I'm sort of an intruder into the field, and so it will take some time to develop. But I think that people that get exposed to these new ideas find them that they explain a lot, that they could be correct. So it's important that it gets better known by more people. And basically, what the winter gatekeeper hypothesis states is that climate change depends on the amount of heat that is transported to the Arctic. So there are several regulators that change the amount of heat that reaches the Arctic, and the sun is one of them. It's not a solar theory, it's a theory of natural climate change, in which the sun plays an important part, but it's not the only one. So, for example, El Niño plays an important role, and also volcanic eruptions act through this pathway. And so it explains a lot of things that right now are not very well explained in climate change. And I think it is important that all these things are considered.
Have you received any responses already to this hypothesis by the academic world?
Well, some academics seem to like it very much, but they are quite a minority, and these are the academics that are not convinced that our emissions are responsible for most of the climate change that has been observed. So, no, I would say it is yet sort of a maverick theory that is not well known and is not obviously accepted. So there is quite a lot of work to do to get this theory better known and better tested, because it is important that other scientists try to prove it wrong, because that's how science works. I would like, the IPCC to demonstrate that my theory is wrong. It's because that's the way science advances. So if they try and fail, then we will know it's probably a good theory.
For our audience, how can you test something like that?
Because theories should make predictions that distinguish them from other theories. And one of the problems with the CO2 theory of climate change is that it doesn't make much predictions at all. So it can explain cooling and warming. So anything that happens can be explained. And this is not a very scientific theory then, because every theory has to come with a way to falsify it. So an important prediction from my hypothesis that could be tested in a couple of decades probably is that, according to my hypothesis, if we get a very active solar cycle, which I expect in about 20 years or so, solar activity will become high again, then we should observe Arctic cooling. And we should observe northern hemisphere winters to become warmer. While the CO2 theory predicts the opposite. It predicts that Arctic amplification is part of global warming. So as long as our emissions continue increasing, global warming continues, then we should still see Arctic warming. So if we see that the Arctic stops warming and starts cooling, then the CO2 theory could not be right. And my theory becomes more probable.
Just one last question. Why are your model and theory more plausible and should be looked at? So could you defend your model?
Okay.
Because science is always a battle of theories and different approaches.
Yes.
And because one theory shouldn't be used as the truth, because we're always fighting.
Yes.
So why is your model maybe better than the models we had before?
We are always trying to approach the truth without ever reaching it, because our theories are always incomplete and are always susceptible to be modified, changed, and improved. So what is good about my hypothesis is, in the first place, it explains better climate change in the past. So if you go back in the past, for the last 50 million years, what you see is that a lot of the climate changes that have been taking place, that have taken us from a very warm world 50 million years ago in the Eocene, back to this very deep ice age we are having now. All this cooling was irregular, so there were periods of cooling, periods of warming, and they don't agree very well with the changes in CO2, except in the latest part. So my theory is able to explain and correlate the changes in climate with changes in heat transport toward the pole due to plate tectonics. And also during this ice age, all these glaciations and interglacials, my theory is able to explain better how these huge ice sheets that cover most of the northern hemisphere were built and how they were melt due to changes in heat and humidity transport from the tropics to the northern hemisphere. So the tropics played a huge role in building those ice sheets, and my theory is able to explain how they did that. And also another advantage is that my theory does not directly compete with CO2. So the CO2 theory is explaining how we affect the climate. My theory is about how natural climate change is acting, and it's a different process. So because my hypothesis is based mainly on the differences in the greenhouse effect with latitude between the tropics and the poles, while the CO2 theory is about changes in global greenhouse effects, so they are minute changes due to very small changes in CO2, while mine is based on big differences in heat transport. So my hypothesis is compatible. It doesn't say the other one is not happening. It's just saying we have to divide the climate change that we observe between both theories. And the more we assign to my theory, the more climate change, the more important it is for climate change, the less important it becomes a human effect on climate. But being a different conceptually and in terms of energy being completely different, they cannot prove that my theory is wrong by proving that the theory is right.
Very interesting approach. One last question. What would you like the science and the people out there to understand or to do and to think about this topic? What would you like to see out there? Which shift in understanding in thinking maybe? What would you wish for?
Okay, the main thing I wish for is by the opening of minds to different ways the climate may be changing, because it seems that we have become too narrow to focus on a single factor, and this in science usually means you are walking the wrong path. So I would like for climate scientists to become more open to different ideas, to different propositions, and to debate them openly instead of just rejecting them. And I would like for politicians and general people and voters to understand that science does not provide absolute answers. It is not a religion. It is not something that you have to believe into it. It's a working process of acquiring more knowledge. So we should not place demands on science that science cannot give. So we have to be prudent, and we have at every time we have to take the decisions that have good balance between cost and benefit, so we don't damage our society and the well-being of people, and we try to preserve nature and at the same time preserve the economy, because our lives depend on the economy.
Thank you very much.
You're welcome.